Mold making.
Here's a cross-cut section of a blanket mold. This is the life cast, the sculpture, water clay, the mother mold, and the base plate. Supports it all. And I'm going to replace the water clay with the silicone. I remove the water clay. This leaves a void. When I fill the void with silicone, this is called the blanket mold. This is wind clay. I call it water clay, and some people actually sculpt with this kind of clay. After time, this clay will harden, so you must keep it covered or it'll dry out. Using a clay cutter, I cut the clay into slabs and then I cover it with plastic. These slabs are about a ½ inch thick. I will also cut some clay about 1 inch thick. There's a large undercut along the base of the sculpture. I spray the sculpture with water and I drape a piece of plastic on top. The water makes it stick better. You need the plastic to protect your sculpture from the water clay. Now I start cutting the clay slabs into strips and start laying them on the base of the sculpture. The water clay is very soft and it's easy to press in place. Lay in the clay strips and working your way upwards. When the blanket becomes silicone, I want the silicone mold to come out of the mother mold easily. So I need to make sure that the clay blanket doesn't have any undercuts. After covering it with the water clay, now it's time to smooth out. And I take a damp sponge and just rub. And be prepared to get dirty, because water clay is quite messy. You really don't want any pockets on top of the clay, because this could form an air bubble when you're pouring the silicone. Using a putty knife, I start smoothing out, and I want to make sure that I'm forming this with no undercuts. If it starts drying out, just add more water. I laid a clay triangle on the mouth area. Then I applied ropes of water clay on top. The ropes are vent channels. This will allow the silicone to flow easier and not create any air bubbles into the silicone. I just smooth out the vent channels with water. Well, this blanket's done. Just clean up around the base plate. I cut a plastic cup. This will make my spout to pour my silicone into. After I make the mother mold, I just sink it into the clay triangle. Now I apply a good coat of Vaseline on the base plate. I cut some more clay slabs. These slabs will be used to create a dam around the entire mold. I lay some clay wedges on the outer rim of the base plate. These are pry keyholes. This will allow me to pry it open. Now I can start laying the clay strips for the dam. If you didn't have the dam, this would lock things in, and plus it's just so messy. One thing about mold making, it's an art form. If you take your time designing a better mold, you'll get great results. When I started laying this blanket mold, I do believe it was about 4 o'clock in the morning. It's a pretty long process. Now the dam is complete. Now I can start doing the mother mold. I will spray a good coat of Krylon's Crystal Clear as a clay separator. When mold making, you need to prep yourself. You need to make sure you have everything handy right there in front of you. Mixer, brushes, burlap. Prepping this makes everything run smoother. I start mixing Ultra Cal 30 and I pour it into the dam area. Using a paintbrush, I help it flow easy. I mix another batch and start at the top. I'm just brushing in the base coat of the Ultra Cal 30. Basically just trying to build up the first layer. I mix up another batch and just repeat the process. Now I add saturated burlap strips to the base plate area and top them with Ultra Cal 30. And I continue building up the mother mold. With each batch I do mix, the batch will get thicker. I soak the burlap strips in water first, then I place them into the Ultra Cal bucket. Now I make the Ultra Cal a lot thicker. Now I start laying burlap strips all over. I mix up a very thick batch of Ultra Cal and start laying it by hand. Building up the mother mold, this will allow me to make a flat top. This top will be the flat base. I lay a piece of plexiglass on top of this, so to create more smoother plane. I used a sponge in my hands to smooth out. The mother mold is finished. I need to allow it to dry. After drying, now I can remove the dam. After removing the dam and cleaning up some, I can use the pry points to open it. You just need to be very careful when prying. You don't want to crack it. This is heavy, and I need to be careful not to damage the sculpture. After opening, I need to remove the water clay from the mother mold, but I'm going to keep this water clay for measuring. Well, here's the mother mold. Now I just need to do some little fine cleaning. Now I take the clay that I used for the blanket, and I'm going to lay it into a 5-gallon bucket. After laying the clay into the bucket, I can make a mark onto the bucket This will indicate how much silicone I will need to mix. Before I start mixing up the silicone, I need to make sure my sculpture is complete. So now it's time for fine detailing. I add some clean clay to the nostril area, and I do some more fine detail work. Now I'm going to start prepping, getting everything ready to pour the silicone. I'm using Molmax 30 from Smooth On. Using a digital scale, I'm going to measure out all my components I need. Measuring A with a digital scale and putting it into the 5-gallon bucket. This too can be quite messy. Please use gloves. Some silicones require you to measure by volume, but this silicone, you need to measure it with a digital scale. Remembering the mark that I put on the 5-gallon bucket that will determine how much silicone I actually need. After measuring Molmax 30's A component, now I need to put the mother mold on top of the sculpture. Spraying a good coat of Krylon's Crystal Clear as a clay separator. This is important. The Roma clay contains sulfur. Sulfur and silicone, they don't like each other. So this is a must. It must be sealed. I'm applying a good coat of Vaseline to the inside of the mother mold and on top of the base plate. This mother mold is very heavy, so I need to be careful on how I lay it on top of the base plate, not damage the sculpture. The mother mold fits great onto the base plate, and I'm also adding a strap to tighten it down. With a hot glue gun, I will glue the base plate and mother mold seam. This will help to prevent leaks. Now I will measure the B component of Molmax 30. I pour B into A. I'll be using a large mixing bit. You must mix these components well. You must make sure that you get along the side of the bucket. They recommend that you vacuum the silicone. This draws out all the air out of it. I don't have that type of vacuum degassing system they're talking about. Some people say it don't work, but I just wanted to try to see if I could do this. I placed the lid on top, and the vacuum I'm using is a shop vac. The small square piece on the lid is a small window made out of plexiglass. I tried to suck out much air as possible. It even collapsed the bucket. Did it work? I believe it did. It did draw bubbles to the top. Now I pour the silicone into the mold. When pouring, I wanted it to produce a thin stream. It took about 10 minutes to pour. Here is another cross-cut view. I turn the mold upside down. Remove the live cast and base plate, and remove the clay sculpture. I will add a thin layer of clay and make the core with a handle. Now it's time to demold. I gave this 16 hours to cure. Now I'm removing the hot glue and prying the mold open. The mold is open now, and now I need to remove the clay from the silicone. After removing some of the clay, now I can lift the silicone out of the mother mold. I turn the mold upside down and remove the sculpture. Here is the silicone mold. It came out beautiful, not one bubble. Using a Dremel tool and a shop vac, I cut keys into the mother mold. These keys are for the core. This is metal key stock with a rolling pin. This will give me the thickness of clay that I need. The clay for the face area needs to be 1/4 of an inch thick. The cellophane that's underneath the clay will prevent it from sticking to the table. Now start laying the clay pieces into the mold. And this is water clay. Oil base won't stick. As I work my way up to the top of the mold, the clay will become thicker, but it still will be less than 1/2 inch thick. You may notice that I'm not going up to the very top of the silicone mold, only these small clay wedges. These will be like small vent holes for the foam rubber. I'm laying some clay on the outer edge of the mother mold. This is a dam for the core. I have black plastic inside the mold. It's just a trash bag cut into squares. This will prevent drying out. Measuring the size for the metal handle and building up this dam here for the core. Once again, mold making is an art form. Take your time. Basically just want to keep the dams level. I needed some more working time, so I covered it with plastic. I apply some Vaseline to the mother mold keys. If you notice, the eyelids have a layer of clay and the eyeballs don't. Doing some touch-up work on the clay vents. Using a ruler, I'm measuring to determine the thickness of the core. Now I'll spray a coat of Cryoline's Crystal Clear for the clay separator. It's time to make the core and prepping for core making. Mixing up UltraCal 30. The core is hollow, so we need to build up a layer at a time. UltraCal 30 has a setup time of 30 minutes. The UltraCal needs to set up some before adding the next layer. This is a slow process. After building up a few layers, I can start adding some burlap strips. And applying a coat on top. Now this is a thicker mix, so this helps a lot. Measuring for the handle and measuring to make sure my measurement is correct. I wrap some burlap around each end of the handle and place it. And I cover it with a thick batch of UltraCal. With a damp sponge in my hand, I can do some smoothing out. Now I can start removing the clay dams. The core is still not set up, but this will make it easier for me to clean up the edges. I chip away on some of the UltraCal, and I also use a plaster rasp. I pulled the core from the mold and started cleaning the silicone. And here's the core. I just need to remove the clay. Just peel it off. And there's the core. I do some light sanding and even get some of the rougher edges off. Now it's time to make the skull mold. Molding the core for the skull mold.
Skull making.
This is core A, clay removed. A layer of mold max 30 was brushed on, followed by a mother mold. Core A removed and returned to mold A. 2 layers of water clay was laid. New core made, core B. Core B was removed and 1 layer of clay was removed. Poured in mold max 30 and closed the mold. The clay was removed. Smooth cast liquid plastic was poured and the mold closed. I'm blocking out the foam vents with clean clay. Applied a thin layer of Vaseline. Mixing Smooth On Mold Max 30 and adding Smooth On's thickening agent. Now brushing on Mold Max 30. Giving the first coat 25 minutes. Brushing on the second layer. Mixed up a thicker batch for the heavy undercuts. Now brushing on another layer. I was budgeted for this animatronic project. There were some sacrifices I had to make. I wanted to brush on a final coat, but I had to save the material for the next process. And here is the brushed on silicone. Now it's time for the mother mold. I cut the clay to lay it along the base of the core. And this is water clay. And trim the outer edge. Just blocking out everything with the clay. And started smoothing things out with water. I built a small dam around the base. I wanted a smoother silicone top, but this is where I had to sacrifice. I took some water clay and filled in some of the heavy undercuts. I didn't want to lock in the silicone into the mother mold. Sprayed on separator. I ran out of Ultra Cal 30 and had to use dental stone. It worked just as good. The disadvantage of this is I have to work faster. Dental stone sets up a lot quicker than Ultra Cal 30. I have built up a couple of layers of dental stone. Now I'll start laying in burlap. The burlap is used for strength. This turntable is actually a TV table. I found it in the trash. After smoothing out, I remove the dam. It's not quite set up all the way. I just need to remove some of this heavy flash. I use this plaster rasp to clean up. Here's a way I demolded. I removed the silicone from the core. I returned core A back to its mold. I need to do some work on the mother mold by filling in these gaps. These gaps were produced by blocking out the support of core A. Using a Dremel tool, I make key marks for core B. I've rolled out thin layers of clay again and laid it into the mold. And this is the first layer of clay. The first layer of clay will be turned into the skull. The second layer of clay will turn into silicone. The second layer of clay will also be the support of the making of core B. These plastic squares will be the divider of clay 1 and clay 2. After laying the plastic, now I will lay layer clay 2. This process will give me a silicone core. This process will give me a polyurethane skull. I did not want to make my skull out of fiberglass. This animatronic is made in my home. I didn't want to use fiberglass because of the fumes. After I applied a separator, I started spreading dental stone and building up layers. And guess what? I ran out of dental stone. I got lucky and found a little bit of Ultra Cal 30, so I was able to finish out the core. The core was pulled, and I had to relay my first layer. So I finished up the first layer again, smoothed everything out. Here's the B core. I applied a layer of Vaseline to it also. Here I'm double checking the fit. I sprayed separator onto the clay. And I allowed it to dry. I mixed up a batch of Smooth-On's Mold-Max 30. And I poured it into the mold. Taking the second layer of clay and doing a measurement, this will determine how much silicone I needed. But it still needed to overflow just a bit. Now after setup, I demolded, removing the core and peeling out the silicone. And placing the silicone back onto the core. Now removing the first layer of clay from the main mold. I'm keeping the first layer of clay for the measurement of how much polyurethane I will be needing. I poured in A and B into a pitcher. With the core already seated, I poured in between the two layers. About 30 minutes later, I demolded. I removed the core, then I removed the core skin. Then I removed the silicone from the mother mold. And I removed the skull piece. And it came out great. Now time for trimming. After cleanup, I made a tracing of the back of the skull. This foam board tracing was cut out. After checking the measurement, I made another pattern. This pattern will be for the back base of the skull. Using the guidelines, I mixed up some plaster and placed it onto the pattern. This is basically a freehand core. Using the guidelines, I made a clay dam. I filled the dam with plaster. This gave me a thin plaster plate. Now I laid water clay on top of this core, smoothing out the water clay. Checking the measurements. This needed to be big so I could hold all the servos I needed. I mixed up some plaster. I built up each side of the back skull. This needed to be molded straight up. I placed a clay shim around it and I dammed. I sealed this with crystal clear. I'm out of silicone, so I must make this mold out of dental stone. This will be a breakaway mold, or a junk mold. The dental stone is setting up quick, so I'll spray a little water on it. I'm laying down another batch, and then I'm going to follow it by laying some burlap. Now a thicker batch. The core can be discarded, but here it is demolded. I laid some water clay. This is 1/4 inch thick. I just followed the mold pattern. And just smoothed it out with water. I sprayed the clay with crystal clear. I covered the dental stone with Johnson's paste wax as a separator, and I started building up layers for this core. As far as sacrificing, I was running out of material left and right, but I had to do what I had to do. I finished the core and I demolded it. So this is how I poured it. And here it is broke away. Urethane doesn't like any kind of water, and there was probably water residue on this mold, which created pockets, or a form of porosity. I mixed up some polyurethane and started patching these bubbles. Waiting for the back skull to fully cure, I start working on the front part of the skull. I'm trimming the skull, and I also have mounted my vacuum. Be sure to use some type of respirator, because the dust can be harmful. Cutting the eyes out was not that difficult. I had the silicone core to go by. I just made my marks and cut it. To cut the slot out for the teeth, I had to get my teeth out of the sculpture. Basically, I knew where the teeth belonged, making the mark for the jaw. Before I cut the jaw, I had to make sure everything was secure first. I had to countersink these metal brackets. I had to drill the hole through the metal bracket into the skull. Now I could remove the jaw. Using a Dremel tool and a crosscut burr, I just followed the line. The area behind the jaw also had to be removed, so this would create a hinge. Making the mark to cut the teeth out to set the teeth in place, and cutting out with a Dremel. This had to be checked carefully. I couldn't get the teeth too low or too high. I mixed up a little dental acrylic so I could make an imprint of the upper teeth. I wanted to be able to remove the teeth when needed. Setting the upper should make the setting of the lower easier. Putting the teeth together and then closing the jaw. This will give me the marks I need for the jaw cutout. Dental acrylic for the lower. Now I will just hinge it closed. There is a layer of Vaseline on the teeth. This will prevent it from sticking. Later I will fit the teeth with screws. For the top of the skull, I needed to countersink these metal brackets also. Just follow the lines with a Dremel tool. Having it countersunk, now I can drill through these metal brackets. After the bracket holes are drilled, now I can cut away. The Dremel crosscut burr works really well. After cutting, I just removed it. This piece of plexiglass is a support table for the eye mechanics. The table is supported with L brackets. The table is set in place. Now I need to make the back of the skull flat. Using a piece of Formica, I did a tracing of the skull. I applied some paste wax for a separator. Then I poured some polyurethane onto the tracing. And I set the skull on top. I use the same technique for the back of the skull. These clay strips is a spacer for the servos. With an angle bracket, I made a dam. Then I mixed up a small batch of polyurethane, just a small batch, so I could just pour it into this area. This will be the support table for the servos. I mixed up a couple of these batches for a few layers, and I removed the L bracket and the clay. With the Dremel tool, I just removed the flash. Now I will remove the top of the skull. I'm using the Dremel tool to cut the lines. And there's the lid for the servos. Now I can make another tracing and design an insert. This had to be designed for strength as well. I laid the clay to make a spacer. I mixed up a small batch of polyurethane and poured it. The small batch is for sealing it. This way it won't leak. After it sets up, I poured 3 or 4 layers just to build it up to the top with the clay. I'll allow each layer to set up some before I pour the next batch. Now I'll just remove the insert. Now it's time for cleanup, removing the flash. After some cleanup, I attached it to the front of the skull. This is for the gimbal. I have 2 metal plates, and in between I have a turntable, or a lazy Susie. The turntable is lifted with spacers. The turntable is for the left-right movement, and this plate here with the L brackets is for the up-down movement. When together, it looks like this. This L bracket here will be attached to the skull, and the gimbal is mounted on a galvanized pipe. Now I need to attach it to the skull by drilling these holes. These go through the L bracket. And here's the left, right, up, down movement. And putting all the pieces together, you get this. Now I'm going to put the pallets in the teeth. First, I grind some around the inside of the denture. This will make the dental acrylic bond. I clean these models up. This is where the acrylic will go. I apply a thin coat of Vaseline to these models. And I mix up a batch of dental acrylic. I put some acrylic in the palette. Then I put the denture on top and blend in the edges, adding monomer for more working time. On the upper, I'll press a little groove. This will make a rouge. And I'll place them in hot water in the pressure pot for 10 minutes. Now clean up and finishing. Now I make these marks on the roof of the mouth to do detail work on the rouge. With the dental lathe, I just follow the lines. And I also stipple it with a stipple burr. This will give it some little divots. The lower palette will be smooth. That's where the tongue goes. I rolled out and flattened a thin strip of clean clay and added a small strip of dental acrylic on top. These pieces of acrylic are support for the teeth. Now I'll drill holes through the denture. I trim up the bracket. I put the bracket into the teeth and put the teeth onto the jaw, and then I add clay to block out. The clay is for where I don't want the acrylic to go. I secure the bracket with dental acrylic. Drops of monomer help to smooth out the acrylic. I repeat this process with the upper denture. I lay a piece of duct tape to hold it in place. Now I will secure the upper bracket with dental acrylic. I push the screws in to make sure everything's lined up. I remove the tape and the denture and start doing the cleanup, removing the clay block out. Back to the gimbal, I wanted to design the mechanics, the up-down motion. I insert a small screwdriver into a servo horn. This will give me a measurement for the placement of the servo. This was a big challenge for me, trying to determine where to lay the servos. This servo was later changed. I was just trying to figure out the mechanics. These L brackets came in handy to where I can make my own servo holders. Using a palm sander, I wanted to smooth out the area that I could lay the servo. Tension springs needed to be mounted on the gimbal and the back of the skull. This would help with the torque. Trying to smooth movements out with the servo controller. Designing the mechanics is a big challenge. I just want to get that fluid movement. I added tension strings to the jaw. I decided to change some things on the servo table. To where I needed my servo to go, it had the hole there, so I needed to fill it. The servo needed to lay horizontal, not vertical. So I poured in some polyurethane in some of the spaces. Here I'm doing some cleaning using the Dremel tool. This servo didn't have enough torque to lift the head, so I'm using this servo for the jaw. I really don't know how many screws I have in this animatronic, but it's a lot. I'm going to cut this out for the servo arm. This arm is attached to the jaw. Now I'm putting the skull together. There are 4 bolts connecting the back of the skull to the front. Here is the servo for the jaw. Notice the arm. The arm will be connected to the lower jaw. The area here will be ground off using the dental lathe. It just needed to be flattened, and I drilled a hole straight through this area. And this is the jaw mechanics. Here I'm attaching the tension springs. The tension springs helps it have balance. Here's the servo jaw test. I'm making a holder for the servo. This servo here is a 1/4 scale servo. I'm making the servo holder out of aluminum L bracket. I'm laying this servo flat. There's a large L bracket coming from the gimbal. The servo will pull onto this bracket. This servo ball stud will be mounted into the servo arm. Here's a servo test with the controller. Here is a computer-controlled test. Now, placement of the eyes. I need to transfer the mechanics of the eyes to the skull. Some of the eye parts needed to be changed. Mounting the eyes wasn't that difficult. I just had to make the room. So I had to cut away some of the eye socket. Now I'm attaching the eyes to the plexiglass. They are attached with 4 screws.
I was made with Smooth-On products. Smoothon.com.
The oven. I had to build an oven to cook the foam rubber skin. It's kind of simple. Basically, it's a big box over a smaller box. This is the base box. This will hold the mold plus the heating element. Here, I'm putting together the big box. This is 2-foot square cube. I'm putting a vent on top of this box. This will allow me to open and close, release hot air, or keep it. I'm putting the big box on top of the small one and hinging the 2 together. And here's the working hinge. The oven needs to be insulated now. I purchased this insulation at the hardware store. It works quite well. I cut it into 2-foot squares and start stapling it onto the wood box. Now it's time for the 8 concrete blocks. 4 of the blocks is to support the oven, and the other 4 blocks will support the mold. The heating element will go into the center. And then on top, 3/8 expanded metal. This will support a lot of weight. I'll be able to turn on the oven here. After putting on the front door and the insulation, it was time for the metal tape to fill the seams and cracks. I drilled a hole on top of the box and then placed the temperature probe inside this hole. I take a 60mm computer fan and I also secure it inside the box. I've cut the lead wires off and just use a simple 9-volt connector. Here's how the mold fits in the oven. Now it's time to run foam to test this oven. I drilled a hole into the core. The lip area has the thickest foam, and I rubbed a good layer of sterilic acid. Sterilic acid is a release agent for foam rubber, and I allow this to dry. You will see a better demonstration of running foam rubber later. This is the first run. I cooked the foam for 10 hours, and this is how it came out. Well, this failed. Why? Because I do believe it gelled too quick, and the combination of my oven. My oven was just too small. I wasn't getting any kind of air circulation around this mold. The mold was just in a tight squeeze, and this is the circulation. So I had to build a bigger oven. Actually, 1 more foot bigger. I built it the same way as the first one, but here's my air circulation. Another foam skin will be ran later. Back to skull work. This is cable housing. I'm just securing it in place and getting the proper measurements. This area here will have some servos, but I need to build a second floor to hold most of them. With a cutout piece of foam board, I outlined it with clean clay to make a dam. Then I poured in polyurethane, smooth cast from Smooth On. Mixed up 1 layer at a time and poured in, allowed to dry between each layer. I simply removed the clay and removed the table. So this is going to become the new table for the servos. Did some finishing work with a dental lathe, cleaned things up. So here's the table. Now I need to secure it in place by drilling 3 holes. Here I'm drilling through the new table into the first table. This will line things up when I set the bolts. I designed it where I could raise it or lower it. Having some of the servos on the bottom floor, and I've cut out sections for the servos on the top floor. Well, it's getting tighter. Now it's time to cut the eyebrows. I drilled a hole first, then I cut it with a hacksaw. After cutting, I finished them out on the lathe. It's a simple mechanic as you see here. I cut a small piece of L bracket. I ground out a small area behind each eyebrow. I'm going to countersink these L brackets and secure them with dental acrylic. I place servo cable connectors to these L brackets. This will allow me to move the eyebrows with cables. I have put this thing together and taken it apart over 20 times. This is the part of fabrication. Everything has to be correct. With the first skin test, I noticed that I needed to close the bite some, so I needed to reset the upper teeth, push them up some. I ground more area out on the upper, and then I ground some on the lower jaw. This will allow it to close. With the second skin test, this is the new bite. I can open up wider now. Now I just need to reseat the upper denture. Placing the upper on the lower and closing the jaw should set things in place. Now I can reset the support bracket just like I did in the beginning. The teeth in place. Now the new foam test. This foam rubber is from monstermakers.com. This foam is so flexible. Looks great, but one thing. I need a throat. I had a small silicone block mold. Just something simple. Something I could cast anything in. So I took it and I placed this clay wedge with some dental acrylic and formed around it. After trimming up some, I took a small block of clay and I covered this with dental acrylic. And I allowed this to set up. I removed the clay and trimmed up some more. Now I needed to fit it onto the upper denture. With a small ball of dental acrylic, I laid it into the roof of the mouth, or the rugae. So I needed to continue this with the throat. This looks very crude, but this is sculpting with dental acrylic. Here I'm blocking out with clean clay. This will allow me to put the acrylic where I need it only. After getting the throat secured to the upper denture, now I can start in the fine detailing, making sure everything fits correct also. Well, the throat's finished. Later, we'll add a tongue to the lower denture. Lips. Now I'm going to show you how I made the lips move and show you the mechanics of lip wires. To make my lips move, I have 4 bolts. Each bolt has a wire holder. In each wire holder, I have a cable housing. This is for support. Here are the 4 lip wire holders. Having the skin on the skull, now I need to determine where I need to place the lip push-pull cables. There are 3 push-pull cables for the upper denture. There are 2 push-pull cables for the lower denture. These holes are being drilled into the skull and into the jaw, not into the teeth. After the holes are drilled, I will thread cable housing through the hole. I removed the denture from the skull. Now I'll drill the hole for the cable holders. I simply push it through the denture. And threading the other holes with cable housing. The wire or the cable that I'm using is actually guitar strings. Now this is primarily a test. These are thinner guitar strings. Just wanting to test to see what I have. I'm not a guitar player, but I noticed something about guitar strings that was going to benefit this project. These guitar strings had a small ring on the end of it, and I could thread another guitar string inside this ring. After threading the lip wire, now I'm going to just do a small push-pull test, see how it works. Now I'll do a simple test with the skin on. Now it's time for the lower. Now I'm going to thread the lower cable housing and put in the cable holders into the denture. Just basically testing right now, but we'll get back on lip wires later. Now it's time to make a tongue. Now I'm going to freehand this tongue with dental acrylic. Now I mixed up some pink dental acrylic. I put some Vaseline on my hands. This will prevent the dental acrylic from sticking to them. I make a ball of dental acrylic about the size of a golf ball. Now I'll start forming a shape of a tongue. There's a piece of thick cellophane in the lower denture, and I will lay this piece of acrylic inside the palette. The cellophane will prevent the tongue from sticking to the denture. After mixing the pink acrylic, you really have anywhere from 5 to 8 minutes working time. And I'm laying a piece of cellophane on top now, so I can make sure it's not interfering with the upper denture. You notice the tool that I'm using to put detail in the tongue is actually a tongue depressor. I'm sorry, I didn't mean to do that. It's a mixing stick. When the dental acrylic starts firming up, you can press it and it kind of forms wrinkles. It's starting to look like a tongue now. Using the mixing stick, I can kind of help the wrinkles out a little bit. Allow it to set up some. I can start doing some little small adjustments. It's getting kind of firm now. I don't leave it in the denture because the chemical reaction will get very hot. Here it's completely set up now. Now I can start doing some finishing. Here I'm just doing some detail work underneath the tongue. And I remove the back part of the tongue. This is where I did some cutout work so I can countersink the hinge. Before setting the hinge, I need to do some pumicing first. And also do kind of a final paint. This is Tester's Model Paint Brown. I coat the teeth and the tongue with this enamel paint, and then I come back and do a wash with paint thinner. You can use vinyl gloves. I just happen to have these bags and I decided to use them, and it's easy cleanup too. The hinge I'm using is just a small, simple hinge. Now I'm going to countersink it into the tongue. I place some dental acrylic, and this is tooth acrylic, and I just place the hinge and kind of get the screw points to sink in. I don't want the dental acrylic to float on the hinge mechanism. This will lock it up. Now I'm attaching the tongue to the lower denture. I'm drilling a hole in the back of the tongue. This is for the mechanics. This rod will give me more support, and this will give it more strength when the mechanics pull the tongue up. And this piece here will be secured to the rod. After setup and finishing, I have a lever mechanism. On the mechanics on this animatronic, I really don't know what to call them. I just did it this way. The ball joint is connected to the tongue lever, and it's also connected to a second lever. This will allow me to move the tongue up and down, but this needs to be attached to a cable, and this cable is connected to the back of the throat. So when the jaw goes down, the tongue will rise. I'm sorry, a mechanical engineer could probably tell you the names, the technical names of some of these mechanics that I have made for the Animatronic Project. In this animatronic, there were 16 servos, and that means 16 movements. And the tongue was number 17, and this is why I had to run the cable. I have cut a piece of L bracket, and this will be turned into a servo holder. I will be having 2 servos. This is for the lower jaw, and these will be connected to the lip wires. I attach the servo holder first and then place the servo. Here I'm measuring the cable housing. And I must make sure that I don't cut too much off. Guitar strings vary in sizes. 42 and 52 is what I use for the Animatronic Project. For the lower I use 42. I thread the cable, or the guitar string, through the cable housing and cut to length. Then I threaded a single piece of guitar string through the wire holder and the guitar strings. The individual piece of wire is the lip wire, and this will be threaded through the guitar strings. The metal beads will be glued down later. And now to check the movement. Now I'm attaching cable locks to each end of the lip wires. I don't cut too much lip wire off. I need to make sure that I have enough space there for movement. This is a wire lug connector. I cut this in half to make me 2 of them, and then I screwed them in place. These lugs will hold the cable housing. The lug can be screwed down too much, and this will create a bind on the guitar string. The longer the servo arm, the longer the movement. The lower lip wires are now finished. Now for the nose. It's just going to be a simple slide mechanism. I basically know where the nose is, so I'm just going to remove this piece of the skull. I just want to remove a small piece of the skull. This piece will be attached to the mechanism, and this piece will be attached to the skin, and the nose will just simply move up and down. After removing the nose piece, this must be sanded. It needs to be smooth. The forehead was done the same way as the nose. Just a simple up-down movement. I even tried adding dental acrylic just to make it smoother, so I could get that more fluid movement. The nose was more difficult. The forehead was just easy. If you notice, I had done the forehead before the nose. The mechanics were difficult for both nose and forehead. I could get them to slide, but sometimes the mechanics just wouldn't work. What saved me was the counter spring, or the tension spring. This allowed me to pull the cable and the spring would pull it back into the place it needed to be. More rigid cables can push, but your flex is gone. For the animatronic, some of the mechanics were difficult. Even though they would work, when it was put together, it wouldn't. So there was things I had to change. This is called fabrication. Well, I had to make sure that I had enough room inside the head to do all the mechanics, plus set the servos, and make sure that I avoided the other movements that they wouldn't bump into each other. Here I'm grinding in some grooves for the cable housing, and I secured them in place with 6-minute epoxy. You have 3 cable housings here. These are for the eyebrows and the center brow, or the forehead. You got another 3 cable housings on the upper denture. That is for the lip wires. I threaded the cable housings to the second floor. Running the cable housings up to the second floor, this would allow me to connect the cable housings to the wire connectors. Here I'm setting up the servos for the second floor. These 4 servos are for the eyelids and the eye movements. Also installed was a large servo, the head movement, and the jaw servo. Removing the plastic covering off the plexiglass. This is the eye table. Securing the eye table in the front part of the skull, then laying the eyes on top of the eye table and securing it in place. This is still a part of fabrication. Everything must be lined up correct. All cable housings are long, but you must not cut these until the very last moment. I have taken the skull apart several times. This is the whole part of fabrication. The cable housing that I'm threading upwards, this cable here is for the up-down eye movement. Setting up the final process of the eyes. I'm using 6-minute epoxy and gluing the cable housings in place. This will prevent the cable housings from moving. This is where I changed the mechanics for the eyes, using guitar strings instead of ball joints. The reason why I'm changing this is because I didn't trust my solder joints, and this really worked well. Threading the guitar strings through the cable housing. And just tightening down the small nut. These are called micro bolts. I had to make sure that they went through the eye of the guitar string. The mechanics for the eyes to move up and down, no guitar strings were used. These are the RC cables that came with the RC cable housing. These are small cable locks. You just push the cable through and screw it down with an Allen wrench. I noticed some RC parts were called different names, and this was somewhat confusing. Setting the eyes in place is a tight squeeze. Seating the eyes in place and pulling cables at the same time, just threading it slowly. Screwing down the eyes. Testing the tension on the cable for the eyelid. I had to make sure that everything was tightened on the first floor because I didn't want to have to come back and take everything apart when I had the second floor in place. Securing the teeth and threading the guitar strings for the lip controls. Now securing the lower jaw. This is a brow cable. This cable is not a guitar string. The guitar string is too flexible. It would not push the brow. Inserting the cable for the right brow. After setting the second floor and adjusting the heights with these nuts. This is a very critical area here. I had to make sure that nothing would interfere with each other. As you can see here, notice the space that I'm dealing with. There's not much there at all. Even some of the servo wires itself would interfere with the cables. Cutting down the cable lengths for the servos. Still, this is not the final cut. I had to be careful not to cut too much cable, because if I cut too much, I'd have to replace the entire cable. This is the inside of the lid for the back of the skull. I tried to make some more room by grinding some of this away. My plans was to put the controller inside the head, but I didn't calculate all the extra cable and cable housing, so I had to drop it. Using these adjustable wire cutters, I was able to cut the cable housing to length and just screw in the cable housing into the connector. You can screw down too much. This will create a bind on the cable and lock the cable up. Connecting the servo arm. Some servo arms are small and some are large. The longer the arm, the longer the movement. But you must consider space and also torque of the servo. Too much torque can hurt the servo. On the Animatronic Project, I always looked at costs. When buying a servo, you need to look at torque. If you're trying to move something that's somewhat heavy or a lot of torque, you need to get the right servo. Don't go with cost, go with torque. Here I'm demonstrating what a cable lock does. This is a wonderful piece of hardware. I only have so much movement for the lip wires. According to my servo arms, I only have so much to move. So I either sacrifice how much teeth I show or how much lip I pull up. I embedded some nuts inside some polyurethane and dental acrylic. These will be attached to the skull. This will allow me to screw on the top lid of the front skull. And I secured them with 6-minute epoxy. Securing the cable for the center brow and placing down the skull lid. These servo controllers are Scott Edwards controllers. One controller controls 8, so I need to chain 2 to make 16. There's a small board underneath the first servo controller. This is a Booster 12. This allows me to use rechargeable batteries. I must solder these wires to make the chaining of the servo controllers. Something about me soldering I just don't trust. You must use flux to get the solder to flow. It's easy with practice. These wire splicers here, there's no solder needed. Just crimp them. As far as electronics, I don't know hardly anything about it. It always discouraged me for trying anything. So I just did it. There's really no soldering on no boards or anything. After securing all the wires, now I can plug up all the servos. And before testing, it's time to run a foam rubber skin.